Good day everyone, I am Maria Angelica Bagnabal from BSED3A, and in this video, I am going to discuss fronts. But before we start our discussion, let me first share the learning objectives of the lesson. At the end of the video discussion, you should be able to define fronts, identify front on a surface weather map or by own observation, and enumerate and classify the different types of fronts. So, let us begin our discussion. So, what does front mean? Front is the transition zone between air masses with distinctly different properties. The differences in density are most often caused by temperature differences. Separate air masses with different humidities as well. So, air masses are massive bodies of air that are constantly moving and colliding with one another. So, because of their distinct densities, cold and warm air do not mix well, but instead, a border between these air masses forms. So, what do you think this border could be? So, this border or that divides the two air masses, which is the warm and cold air, is what do we call fronts. In addition to this, when a front passes over an area, a change in the weather will most likely to occur. Many fronts cause weather events such as rain, thunderstorms, gusty winds, and tornadoes. More so, we identify fronts by the movement of this transition zone and the properties that move over a geographical location. So, major weather changes occur along the boundaries between the different air masses. And these boundaries are called transition zones that, for practical purposes, can be considered as discontinuities and frontal surfaces. So, how do you think fronts develop? Fronts arise from time to time in a variety of locations around the Earth's surface. However, what has been mentioned about frontogenesis suggests that the development of fronts happen more frequently in different geographical places, notably when the formation fields prevail with an appropriate temperature gradient. So, as I've said earlier, fronts occur in different geographical places. So, I have here a question. Do you think we are able to identify fronts? If yes, then you are right. Through our own observation, we are able to identify front on a surface weather map or by our own observation. So, all we need to do is to look for these five signs. So, first is we have the sharp temperature changes over a relatively short distance. Second, change in moisture content. Third, rapid shifts in wind direction. Fourth, pressure changes. And fifth, clouds and precipitation patterns. So those are the things that we need to observe for us to know or identify fronts. If we observe this occurrence in our places, then there is a possibility that fronts will most likely to occur. So now that we know the definition of fronts and how we can identify this, let us move to the type of fronts. And there are four types of fronts, namely stationary front, cold front, warm front, and occluded front. Let's first start with stationary front. So based on the module, stationary front is characterized by no movement of the transition zone between two air masses. From the word itself, stationary, no movement occur. Forms when warm and cold air meet and neither air mass has the force to move the other. They remain stationary or standing still. So here, when a cold or warm front stops moving, it becomes a stationary front. This happens when two masses of air collide, but none is powerful enough to move the other. So winds also plays a vital role in fronts. So in stationary fronts, winds blowing parallel to the front rather than perpendicular, which can help it stay in place. In addition, stationary front can remain motionless for days or can stay for days. Thus, if the wind changes direction, the front will begin to move again, becoming either warm or cold front, or the front may break apart. So, because stationary front separates two air masses, which is warm and cold air, there are frequently differences in air temperature and wind on opposing sides of it. So, as you can see here, stationary fronts are represented by blue and solid lines with alternating blue triangles and red semicircles on a weather map. So, what does it mean? So, the blue triangles point the warmer air, while the red semicircles point toward the colder air. So now, let us discuss the second type of fronts, which is the cold front. A cold front, based on the module, is defined as cold air displacing warm air. Steep leading edge, friction slow surface advance, moves quickly 25 knots up to 40 knots faster, steeper, which is steeper. Forms when a cold air masses pushes under a warm air mass, forcing the warm air to rise. So here, when a cold air pushes into a warmer air mass, a cold front occurs. Cold front may cause drastic weather shifts. They can travel twice as rapidly as warm front. When a cold front approaches, the heavier or denser cool air pushes beneath the lighter or light dense warm air, forcing it to climb into the troposphere. Cumulus or cumulonimbus clouds and thunderstorms are produced by lifted warm air ahead of the front. So let's proceed to the table. So winds become gusty as the cold front passes. There is a sudden drop in temperature as well as heavy rain, occasionally accompanied by hail, thunder, and lightning. So at the front, atmospheric pressure shifts from falling to rising. Following the passage of a cold front, you may notice that the temperature has dropped, the rain has stopped, and the cumulus clouds have been replaced by stratus and stratocumulus clouds or clear sky. So now, let us move to its symbol. So as you can see, the symbol of cold front are represented as blue solid lines with triangles on a weather map. It means the triangle are pointing towards the warmer air in the direction of the movement. Next, we have the third types of front, which is the warm front. So, a warm front is warm air displacing cool air diagram. Shallow leading edge warm air must overrun cold air. Cold air recedes moves slow 10 to 15 knots. So here, when a warm air mass pushes into a colder air mass, a warm front develops. So warm fronts travel more slowly than cold fronts because warm air finds it more difficult to push cold, dense air over the Earth's surface. So, as we can see here in the table, a warm front is frequently accompanied with high clouds such as cirrus and cirrostratus, as well as medium clouds such as altostratus. So, these clouds originate in warm air that is located high above cool air. As the front moves across an area, the skies decrease and rain is expected. So, if the air is unstable, thunderstorm may form near the warm front. So, now let us proceed to its symbol. So, as you can see, the symbol of warm front is represented as red solid lines with semicircles. The semicircles are pointing towards the colder air in the direction of the movement. So, kung kanina sa cold air, it is represented by blue lines with triangle. Dito naman sa warm air, it is represented as red lines with semicircles. So, now let us discuss the last type of front, which is the occluded front. So, an occluded front forms when a cold front overtakes a slower moving warm front. So, a cold front might arrive shortly after warm front. So, a warm air mass pushes into a colder air mass, which is subsequently pushed into another cold air mass. So, because the cold front moves quicker than warm fronts, the cold front will most likely to overrun the warm front. This is referred to as an occluded front. So, at an occluded front, the cold air mass from the cold front collides with the cool air ahead of the warm front. So, as these air masses collide, warm air rises. Occluded fronts typically arise around low atmospheric pressure regions. So, there are two types of occluded fronts. So, as I've said, there are two types of occluded fronts. So, what are those? So, that is the cold and warm. So, in a cold occlusion, the cold air mass overtaking the warm front is colder than the cool air ahead of the warm front and flows under both air masses. So, in a warm occlusion naman, the cold air mass overtaking the warm front is warmer than the cool air ahead of the warm front and rides over the colder air mass while lifting the warm air. Lastly, let us have the symbol of occluded fronts. So, the symbol of occluded fronts are represented by purple solid lines with alternating triangles and semicircles. So, the alternating triangles and semicircles are pointing towards the direction of the movement of the fronts. So, since sabi nga natin kanina sa occluded fronts, dito pumapasok yung warm and cold air. So, yung sign niya is alternating triangle and semicircles, which represents the warm and cold and warm air. So, that would be all in fronts and the type of fronts. So, once again, I am Maria Angelica Bognabal from BSED 3A, and thank you.